Hello, my name is Emmanuel, and I am a teammate. We talked about working on a project, and the reason why we came up with this project was based on the problems that we've understood based on industries. And first of all, before coming up with this project, we had to go to industries, look at what exactly are their problems and how we can create a solution to help them solve this problem. And one of the things that we noticed was, every organization they deal with one particular problem. And that problem is what? Is waste. And waste, it's something that, schools, industries, food industries, because it's an everyday, waste production producing, world where we use stuffs and we have to dispose them. And also again it comes with the use of recycling and doing a lot of reposition and cleaning all those things and making them useful for proper usage. And I and my team member thought about finding a solution to properly classify this problem for industry so we can reduce their stress and see it as a product to help integrate a better system that works. So we came up with a smart waste classification system. So I, Paras, Priya, Sujit, and Rudvi, we came up with this project plan. And this project plan, works based with use of CNN, which is an artificial intelligence, software, program based on machine learning and different AI processes and workload. So the problem basically is global. It's a global issue basically, and we thought about using AI to automate this process. And with the use of AI, we did classify products based on different data sets. With the use of cardboard, with the use of glasses and paper and plastics. So majorly, why did we pick? Because these are major garbages that we are known to use every day. We're known to that everyone dispose and put into the garbage can. And how can we properly segment this properly and help organizations like industries in food industries in schools to help them properly segment their waste and keep it clean from keep it not mixed together and properly classified. So we came up with a smart waste classification model, and we used different algorithms with the use of CNN, the convolutional neural network, we worked with image classification. What we're trying to do basically is to work on an image classification whereby if you put a paper, it tells you that, oh, this is a paper, then you're putting it in the correct disposable bin. Or you're working with the use of plastic and it's the sensors or the camera is seeing that, oh, this is the plastic, and it's going into the right disposable bin for proper segmentation and recycling if needed. So this is kind of like an automation we've been able to build, and also to be able to help organizations solve this problem, and them seeing that, oh, this problem is being solved, and they can come to us for proper reasoning and how they can buy our product. So we did some data pre-processing properly, based on machine learning and CNN model, AI algorithm, and as well we had a structured model. So based on our model, we used several models. First of all, we decided to create a baseline model where we used our own, own structure model we built instead of using a pre-trained model. Then after that, we noticed that we're able to train our data set based on these models and also see how best our base model perform. Then we thought about also using a pre-trained model to also work on, all our data sets. And based on this, we noticed that the pre-trained model, the baseline model, did perform but was not up to expectation of what we wanted, because we did got a baseline model accuracy score of about 75%, and we thought about using the pre-trained model to see what we can actually work on. So from here you see that this is an architecture of the model we created, the baseline model, the inputs, the convolution layers, and also how we flatten it. Then we see how we predict based on, if this is plastic, it goes to plastic. If it's paper, it goes to paper. If it's to metal, it goes to metal. Cardboard as well, with the rest of the categories we place them on. So this is how our model performed. So our model from scratch performed about 75%. VG16 80%, and our best model was the ResNet 50, which is 93%. So the best performance is to get to close to 99 or 100. So what we did is to create a precaution for the rest of the percentage that is left. So we created a form of precaution to see, okay, why is the model not performing to an higher accuracy, but we're able to get 93, which is good for for basic representation and predictions. So we did also work on, okay, this is like a live view of how it is on the laptop when we're building the model. This is before the uploading. So we used Flask, HTML, and Tailwind CSS to kind of structure like a web-based classification process that makes it easy for us to test our model, see if it's working properly, and also be able to apply it. It's kind of like an MVP to apply it on the word use scenario. So this is the before and this is the after. So after, you see that, okay, we did show the image and the image was able to classify correctly. Then this is an OpenCV. So we thought about using an OpenCV tool as well, so which we worked on. OpenCV in the sense that when you put a paper directly on your screen like this, it predicts that, oh, it's a paper. If you put a plastic, it predicts that it's a plastic. As well, we did that too as well. And why did we do this? Is to solve problem, because every industry deals with one particular problem, and problem is waste. For the industry, they deal with waste problem. School industries, they deal with waste problem. They dispose paper, documents, after written documents, they tear paper and put it in the bin. They deal with same waste products every day, and best solution is to how best can we classify these wastes. And this is why we came up with this projects to be able to help industries resolve these issues of waste in their organization. So we came up, we did add some limitations, but we were able to receive it and put precautions on this limitation, because we were working on with a very low space capacity. It's kind of computationally expensive, and but we had to come up with an MVP that can actually help our solutions to work properly. And thank you for listening. So one of my team members is going to show you a demo of how what we've done works, and to show you what we've done and how we can proceed with the MVP. Thank you.